Okay, hello, good morning, guys. Today we'll be discussing about our SEL, which is linear transformation. So for the first question, 1B, okay, given TAX squared plus BX plus C equals to A bracket X plus 1 square plus B X plus 1 plus C. So we want to prove that assume that P1x equals to A1x squared plus B1x plus C1, and we assume P2x equals to A2x squared plus B2x plus C2. So we want to prove whether it's we want to prove the additivity property. So first, we add P1x to P2x. We get A1 plus A2 x1 square plus B1 plus B2 x1 square plus C1 plus C2. And then we expand everything. And then we group it up and we get A1 plus A2 x square plus 2A1 plus 2A2 plus B1 plus B2x plus A1 plus A2 plus B1 plus B2 plus C1 plus C2. So after that, we do it one by one, where P1x plus P2x. So we get the same answer. Since both of it is equal, the additivity property holds.
Okay, next is for the multiplication property. So as you can see that when k multiply with the px, we will get expanded value of ka x square plus kbx plus kc. So when we add the transformation t kpx, we will expand it by ka x plus 1 square plus kb x plus 1 and then kc. So if you go further, expand and simplify it, you'll get ka x square plus 2ka plus kbx plus ka plus kb plus kc. So since we want to do the right hand side of the equation, which is k multiply with the transformation of px, so k at the outside, so ax plus 1 square plus bx plus 1 plus c, and then you expand and simplify the inside equation, we will get kax square plus 2kax plus ka plus kbx plus kb plus kc. So therefore, t transformation of kpx equals to k transformation of px, and the scalar multiplication property is satisfied. And therefore, Tax square plus Bx plus C is a linear transformation.
So for question 2, we are given two linear operators, T1 and T2, which transform a polynomial Px. So T1 is given as Px, Tx is given as Px minus 1, and T2 is given as Px plus 2. So P3, it represents the set of all polynomial with degrees up to 3. This means a polynomial in P3 can be written as Px ax cubed plus bx squared plus cx plus b. So for the question B, it's asking T1 circle T2 Px. The circle symbol represents the composition of two operations. So this means we will apply T2 first, and then we will apply T1 to the result. So Calvin will continue.
So because it's the composite of T1 and T2 under Px, so T2 Px, as already mentioned by the question, is basically you get T2 ax cubed plus bx squared plus cx plus d, and then after that you get a x plus 2 cube x plus and then bx plus square, and then cx plus z plus d. And so when this goes under T1, it becomes ax minus 1 plus z. It's a ax minus 1 plus 2 cube plus b x minus 1 plus 2 cube s square plus c x minus 1 plus 2 plus d. Lastly, you get a x plus 1 cube plus b x plus 1 square plus c x plus 1 plus d. So that's T1 composite T2 under px, we will get px plus 1.
Okay, so now I'll be explaining on question 5. Given the T is from R3 to R3 and matrix A is 4, 5, 7, negative 6, 1, negative 1, 3, 6, and 4. The question asks to find a basis for kernel T and basis for range T. So the first step will be, in order to find the basis, we will take AX equals to 0. And then we will be finding the elementary row of operations for matrix A. So we start off with reducing row 1 by multiplying 1 over 4 to row 1, and then row 2 is equals to row 2 plus 6 times row 1, and then row 3 is equals to we multiply 3 with row 1, and we take row 3 minus with 3 row 1. And then we multiply 2 over 17 for row 2, and we obtain this. After that, we take row 1 minus 5 over 4 row 2, and at the same time for row 3, we take row 3 minus 9 over 4 row 2. And then we multiply negative 17 over 64 for row 3, and finally, row 1 is equals to row 1 minus 6 over 17 row 3. And then for row 2, we take row 2 minus 19 over 17 row 3, and we obtain a full rank matrix. Now I'll pass it to Shamira.
Since the reduced row echelon form is identity matrix of A, that the kernel T only contains 0 vectors. The basis of kernel T is a trivial solution. Since the rank of A is 3, hence the basis for range T is given by the original column of A, which is the first column 4, negative 6, 3, and the second column 5, 1, 6, and the third column 7, negative 1, and 4. So that's all from us. Thank you.